Here we're looking at two different pressure transducers that are tied back to the 326A. We have the transducer that's in the receiver and also the transducer that is on the outlet of the gas cooler, monitoring the high pressure, what we call the high pressure in the system. So when we look at our enthalpy diagram and where those pressures relate and how the EKC-326 reacts based on what that pressure is, we can see we have some settings that we've pulled from the 326A manual and attached them to the graph here. So if we look at our receiver transducer first, we have a parameter N71. And this would say if our receiver pressure gets down below a certain threshold that we've set in the controller in the 326A, that we would start to force actually the high pressure valve. So normally our ICMTS, we would start to force that open to build pressure back up in the receiver and kind of bypass whatever the normal control was telling that high pressure valve to do.
So Chris, what would be like some of the ranges? Because I've seen a few different ranges, but what are some of the ranges you see manufacturer putting in there for this minimum receiver pressure? Because if you get too low of receiver pressure, you can't move that liquid properly. You're not going to feed the metering devices properly. What would be like kind of a range you may see or you have seen over the years?
Yeah, I think when the system started years ago, 500 psi, just for your not for your low pressure setting here, but for kind of just your standard control point, was pretty typical for the systems that I was involved in. And then here over the years, we've seen that deadband, I'll call it, spread out, where we're now shooting in some systems a little higher than that, especially when we get into things like parallel compression. You could see 525, 550, maybe even pushing 600 psi. Sorry, we'll talk psi here. But then maybe even because the controls are becoming smarter too, we again give a deadband where maybe you can even run that standard set point a little lower. So minimum receiver pressure, I'd say just kind of a ballpark, maybe 450 psi, somewhere in that range is normally where I'd see this setting. Set to.
Definitely same here around that. And it's different depending on the manufacturer. You got to follow what the manufacturer suggests and check their thing though. But 450, I would say, is a good number. But you're right. I've seen receiver pressures up to 620 psi because of air conditioning. They're using, they're doing real high temperature applications. So higher pressure receiver. So it may be a little bit different for that minimum receiver pressure N71 parameter.
Exactly. And then we have another parameter tied to the receiver transducer here, N58 in the EKC-326A. And these are all settings that would also be a 1-for-1 in our pack controllers as well, but on the max receiver pressure. So we don't want the receiver to get to a point where it's going to blow the relief valve if we can do something about it. So here with this setting, and this would be where you're getting closer to that 600 psi range. This is where we would have the high pressure valve start to actually throttle closed outside of what the controller is already telling it to do, so that we don't build up pressure on the receiver to where it's going to hit that relief valve and pop off.
Yeah. So, and this is so important because different manufacturers, someone might have designed the system for 600 psi, some may have designed it for 650 psi. And so this is important to make sure you check that, because if it's a relief of 600 and you set this one here for 625, just for an example, that relief is going to go because it's going to think, well, I'm still good. I still got range. What does the N59? I see it says the P band, and then you have N72 as the P band. What's the difference between those two?
Yeah, so the P band is kind of a dead band. I think is maybe a more common term that a lot of people would be able to relate to. But basically there, it's when we're kicking this safety feature into gear, whether it's on the low end of the receiver settings or on the high end, we're not just using a hard cutoff or a hard set point. So if we had 600 psi, let's say, as this setting in N58, there's also an N59 that says gradually as that pressure continues to increase, if the high pressure valve was at 80% when we hit this point in the receiver, it'll gradually go up towards 100% open over that 600 plus the P band setting. So if the P band were at, say, another 30 psi, we'd start to override that valve open at 600 psi. And then once we hit 630, then that would be the point where the valve is fully closed on the high side.
Okay. So that's a good point. So that means potentially your valve, high pressure valve, could be 100% closed because you're above the P band. So 600 plus 30 would close that valve to make sure, well, listen, we're too high. There's something wrong. We got too much pressure in that flash tank receiver, and we got to close off.
That's exactly right. So somebody that's looking and sees that the gas cooler pressure is really high and doesn't understand why the valve isn't opening more, they may need to look at some of these settings to say maybe it's happening for a safety reason because of where the receiver pressure is at.
And I see on here it says no alarm, so you wouldn't have an alarm for that. You need to actually go in and look at the pressures and these different P bands to understand it. And that would be the same thing for forced opening, the N72P.
Correct. That's correct. The P band applies in the same way. So when we would hit, say, a 450, if we had a 30 PSI P band programmed in on this N72, we would actually start to throttle the valve, the high pressure valve, open at 450 until it dropped all the way to 420 when we would be at a spot where that valve is fully open.
Okay, great. And then I see N91, it says receiver reference. So that would be that set point that you're looking for, say 510 PSI in the receiver, 520. Is that correct?
Yep. Yeah, that's your normal control point. If all other conditions are kind of within range, then yeah, N91 would be that 500, 525 typically that we're shooting for, just with and that's the flash gas bypass valve on the outlet of the receiver that we're using to try to maintain that set point. We do have on the flip side too, with the pressure in the gas cooler, you can see on the right side, we have some settings here, N69, N81. I know they're a little tough to see with some of the red lines going up the graph, but parameters where we're going to also use safety conditions with the pressure at the gas cooler. So you can see very high up on the graph, up around 100 bar. If we hit pressure with the transducer that's at the outlet of the gas cooler here, this can force we say ICMTS here, this could force the high pressure valve open. So if we hit that 100 bar mark, depending on what it's programmed at, we'll start to open that valve up some to relieve the pressure in the gas cooler. And then on the flip side here, we can start to close the valve down if the pressure in the gas cooler is not high enough with this setting N81 for minimum gas cooler pressure. So these settings all play into one another. You have to make sure you're not overlapping a high receiver pressure setting with a low gas cooler receiver setting, because then some of these safeties can kind of fight one another. And you can have very erratic control.
That's a great point. And I think that's where a lot of like setup could be an issue, is where they have overlapping and it's causing the valves to fight each other. So for an example, if you have the N69 set for 100 bar, that's 1450 PSI, and it's really hot out, it's 110 out, 120, you're getting up to that pressure. If the valve is, say, only 80% open, and then you hit that 100 bar or 1400 PSI, it will just open the rest of the way up. Is that correct?
Exactly. Yeah. And most times I would expect this to already be open, but it is a safety feature that's in there to say, if we're not already, we're going to make sure that we take that thing immediately to 100% open after we hit the N69 plus the B band there, to make sure that it is fully open.
Okay. And then the same thing for force closing, N81. So that's that minimum gas cooler pressure. So this would be important for the middle of winter. Like here in Canada, it gets really cold in the winter. If we get a pressure that's like it's minus 35 Celsius out or minus 40 Fahrenheit, some places here in Canada, you get so cold, you need to set that up properly, because if that's too low, you could run into a lot of issues with flow. Can you talk a little bit about that and what you've seen?
I'd say we normally keep this maybe 50, or at least what I've experienced, maybe about 50 to 100 pounds above what our receiver, our max receiver pressure is, so that we make sure we have some differential there between what the gas cooler is at and where our receiver is. This setting, the minimum's normally somewhere in the 600 to 700 PSI mark, I'd say.
Yeah.
Compared to, again, what the receiver's modulating to.
Yeah, and then there's no P band with that. So if you have it set for 525, that PSI receiver pressure, you'd have this set maybe for 625, for an example, as N81 for minimum gas cooler pressure. And then the last one, low gas cooler alarm, N65. What is that for? What is that really used for?
This is more just a notification, so no action per se within the controller where it's going to do anything with the valves. That's already been done by the time you hit this point with the other settings that we've got in play. This will be more of just a notification. If with the EKC, it would be an indicator that's on the display on the front of the controller. And then if you've got alarm contact you're using off of the EKC, then it would trigger those alarm contacts.
Fantastic. Like, and that's the key to understanding this controller, is understanding how these valve works, and that was perfectly explained. Thanks, Chris.